Okay, so thank you for joining us today. My name is Ihor Dvoretskyi. I am an operations engineer in Mirantis. Mirantis is the #1 player in the OpenStack world. We are the biggest contributor and biggest bug fixer, and possibly the most active community member in the world of OpenStack. And today we'll speak about a few things related to the OpenStack and Kubernetes. Before we start, I'd like to ask you a few questions. Are there any people who are familiar with OpenStack? Good. And with Kubernetes? Possibly Docker? That's good. Okay, that should be useful for you. So today we'll speak, I'll tell you a few words about OpenStack. Why should we use it for some purposes? What are the benefits of usage of OpenStack? From what components does it compose? And why that is a really popular solution for building private clouds. I'll also describe here a few words about one of the most fastly driven projects in OpenStack world named Marana. That is an application catalog that is originally has been developed and actively contributed to the current moment also by Mirantis company, and that allows you to run a few applications on your OpenStack cloud. I'll also say here a few words about containers, what are the benefits of using containers in your environment, and what are the main purposes of containers, what are the pros and cons compared with classic virtual machines. And after that, I'll describe here Kubernetes, possibly their most popular and the really leading tool in managing container clusters and containers themselves. And at the final, I'll show you a little demo how to run Kubernetes on OpenStack, and I'll show you some few tips and tricks regarding that. So what is OpenStack and why the most people for building private clouds use OpenStack? First of all, OpenStack is totally free and totally open source cloud computer software. That's a set of tools that allows you to build your own private cloud on your own hardware in your, for example, own data center, and customize it specifically for your purposes. You may use OpenStack as infrastructure as a service. That's the main concept that is fit by OpenStack. So when you deploy OpenStack on some environment, you receive the whole infrastructure-ready environment where you may run another applications and other virtual machines. You may deploy some networks there. You may deploy some volumes, for example. You may also attach some vendor-specific tools. You may also extend it with some other plugins, and so on, so on. So that's really a really big system. That's really flexible system. That is really useful system for building private cloud. And regarding some polls, OpenStack is the most popular open source cloud project in the world. Not only cloud project, to be honest, but at the current moment, OpenStack is #2 from the whole open source world after Linux. Regarding the community activity, regarding the activity of contribution, regarding similar things. Docker and KVM have really huge activity, really big communities they have, but they have that not so big as OpenStack has. A few words about Marana. So Marana, first of all, that is an application OpenStack-based application managed tool. So using Marana, you have possibility to deploy your applications in a few clicks. For example, you may simply go to their community app catalog, find their package named, for example, Nginx, and run it really in a few clicks on your OpenStack cloud. First of all, Marana is really an application management catalog. Is an application management tool. So Marana allows you to run either to use the global application catalog. It might be compared with Docker Hub, for example, when we're speaking about Docker containers, where the whole contributors from all over the world contribute their containers, their container images there on the Docker Hub, and you may receive that container, that image to deploy your own container. At the same time, Marana Global Application Catalog has the same purpose. So you are allowed to deploy there, to submit there some of your application configuration files, and anybody who would like to use them may go to their application site and download it. Otherwise, you may also deploy your own repository of these applications, and they will be really private for you, for your company, for your organization, and so on. So Marana project is really open application catalog, and all of these applications that are published into community app catalog, the public one that is accessible by anyone, they are published at this site. It's apps.stack.org. You may visit it and you may find a couple of applications there. There are not so many applications there at the current moment because this project is only in the starting point of its own development, but in the nearest future you'll see a huge amount of applications there. At the same time, you may also view the source code of these applications. It is being published on GitHub. This link will provide you the source codes of these applications. One of the main purposes of Marana is to enable OpenStack as a platform as a service. So as I told you before, OpenStack in a classic form is an infrastructure as a service. So using OpenStack, you receive your infrastructure there. Using Marana, you receive a single ready-to-use platform to deploy, to manage, to work with your application. So you shouldn't deploy anything manually. You shouldn't provision virtual machines. You shouldn't recreate networks with some custom configurations. You shouldn't deploy volumes, for example, for storage. All of those things are being provided by Marana. So when you deploy application using Marana, you simply have to code. You have to provide code, run that application, and that will be enough for you. And also one really big benefit of Marana that it supports multiple OS versions. So you are allowed to build your applications not only Linux-based, but also Windows-based for someone that might be really useful. A few words about Marana architecture. This diagram looks like really not so easy, but globally Marana is really an easy tool to understand how does it work. So the first component that we may see when we work with Marana is Marana dashboard. It's Marana UI. When you open the OpenStack web dashboard, it's named Horizon. You may simply take a look at a few options that allows you to create environment, to add there some applications from the global catalog, to deploy them, to configure them, to deploy the whole environment, so on and so on. So I will show you this UI later in our demonstration. An alternative to the web UI is a Python Marana client. You may simply perform the same operations from the command line. So it is Python based, and you may simply run the same actions. You may also deploy your environment, for example, import your packages and so on, using the command line. Marana dashboards connects and speaks with Marana API. Marana API is a classic REST API that is attached to the RabbitMQ queue that is messaging protocol, if somebody don't know what is RabbitMQ. So Marana API sends tasks to the RabbitMQ, and after that, RabbitMQ sends them to Marana engine. Marana engine is a core component of Marana as a component of OpenStack. So Marana engine listens to the task from RabbitMQ. It receives it, and regarding to these tasks, it sends API calls to HIT. HIT is a component of OpenStack that is something that we may compare with, for example, OpenStack CloudFormation. So that's a tool where you are allowed to write a simple configuration file to declare that state of infrastructure that you'd like to receive, and using that file, deploying your infrastructure with HIT, you'll receive in a few minutes or in a few hours, related to the size of your infrastructure, you'll receive your infrastructure in that type and in that configuration that you have described in your configuration files. So Marana engine sends API calls to HIT API, and also Marana engine sends tasks to their agents. The agents that are located on the guest virtual machines. To deploy some application using Marana, you have to use a pre-created image for OpenStack with Marana enabled agent. If you haven't similar image, if you haven't found the similar image in a global repo, you may simply deploy it in a few steps. This information is really globally described in the documentation to Marana. So Marana agent is located on a guest virtual machine. It receives the tasks from Marana engine, and it performs the task. So if you have to deploy some application on that virtual machine using Marana agent will provide it work. And after successful or unsuccessful deployment, Marana agent will provide the return answer to Marana engine, and we may receive the result. We may see it as a web UI or in a CLI after our process of deployment. So a few words about containers. First of all, I'd like to explain a bit current slides. So the most of things that are described in these slides are related to Docker containers, but possibly 90% of described information is also related to other types of containerization like Rocket, LXC, OpenVZ, and something similar. But Docker is the most popular container product at the moment in the world, in community. So first of all, the container products that are being deployed in the current days are provided regarding their Docker possibilities. So first of all, Docker is a lightweight isolation technology that are containers. And Docker allows you to run some applications in these containers. So first of all, Docker management of Docker containers is rather different than managing of a classic containers like OpenVZ or LXC. So first of all, you should understand that when you manage Docker container, you're managing not a virtual machine, not a dedicated application that is deployed on a big host. You are managing Docker container with an application. And containers have really some huge benefits that are really great benefits for you if you'd like to use Docker containers for some of your purposes. First of all, that the Docker containers have huge performance. They're much faster. They perform much smaller overhead when we compare them, for example, with classic virtual machines. Docker containers provide you a great repeatability. In a few seconds, you may deploy 10, 100, 1000 containers from one image, and that will be totally easy for you. Another thing that is a great benefit of using containers is isolation. So if you, for example, have a couple of applications that use the different types of libraries, for example, or shouldn't communicate with each other, shouldn't have any relationship with each other, you may use Docker containers for that. You simply pack your application into one container and it will be totally isolated from their neighbors. And possibly the biggest benefit of using containers, the biggest positive feature is portability. So you simply should deploy your code, you may pack it into a container, and after that you may launch that container anywhere. You may launch it locally on your Docker machine on your, for example, Linux PC. You may use these containers on a Vagrant virtual environment. You may also deploy these containers, for example, on Amazon, on Google Cloud, on OpenStack, and somewhere else. So the only thing that you have to run Docker containers on your some specific environment, you should simply have a Docker-enabled environment. That's all. So in this table, I will describe here in brief the main difference between containers and classic virtual machines. So first of all, as I told you before, containers are built for managing applications that are not built for managing the virtual machines. When you use container, especially Docker container, you use it for running your application. So simply pack code and run the application in a container. When you manage the virtual machine, you have to use the whole ecosystem for managing that virtual machines. For example, when you use the KVM-based solution, you have to provide for your virtual machine, you have to provide some kind of network, some amount of computer resources, some amount of storage resources, and so on. For Docker, you shouldn't perform that. So Docker containers are not playing on the infrastructure layer. So it is below them. Also, there is a huge difference between Docker containers and classic virtual machines regarding guest host support. So for production purposes, you may only use Linux-based containers. So at the current moment, there are some works from Microsoft regarding to the possibility to run some Windows-based applications in containers, but at the current moment they are not ready for production use. So if you'd like to run some code in a container, you have to deploy on some Linux base. In a classic virtual machine, you may deploy any operating system that you like. You may deploy either Linux or Windows, or possibly some BSD systems and so on. So the most common virtual machine solutions allow you to run the different kinds of operating system. The big difference is in performance. So containers do not incur any overhead. When you run containers on your host, the infrastructure of container engine provides you possibility to run them as a simple application. So from the point of view of your operating system, you will see these containers as a simple applications on that host. When you run some virtual machine on a hypervisor, you will receive the huge overhead of resources. So that's not so good, because regarding to some metrics, as far as I know, when you run virtual machines, for example, in KVM or ESXi enabled environment, your overhead will be approximately 10 or 15 or possibly 20%. That's not so good. That's why if you have the limited resources to run your applications, run your to virtualize your environment. If you have possibility to use containers, it would be a much better solution for you to use containers there. And also there are some not the issues, but some features regarding their security when we compare containers and virtual machines. So when you run the virtual machine on, for example, KVM-enabled environment, your virtual machines are fully isolated from each other. So they have no possibility to connect to each other, to speak with each other, to possibly have some security issues that may incur some issues on another virtual machines. Docker containers are being using the shared Linux kernel. That's why if there are some issues or vulnerabilities that allow some code to go outside of the container, other containers will be also affected. And the final one is application management. So containers are managed as a code. So first of all, if you manage some container-based solutions, you have to manage that not as an infrastructure, but as a code. So you may simply deploy your containers using some clustering tools, like for example Kubernetes, about which we'll speak in a few minutes later. When we are working with virtual machines, we should work with them as a fully loaded environment. Process of managing the virtual machines is not so different when we compare it to the process of managing the bare metal deployed systems. So Kubernetes. Kubernetes has been originated as an open source product, as an open source project of Google. The latest approximately 10 years, Google used a similar container management system named Borg in the infrastructure. So the most of the services that are being provided by Google are running in containers. So Gmail, Google Maps, possibly another services are being run in containers, and they were managed by Borg. That's their proprietary internal system for managing containers. And at the same time, there are the best things that Google received from deploying from using Borg in the infrastructure. All of these things really had a great influence on Kubernetes. So when you use Kubernetes, you use, first of all, there are similar system as Borg is being used by Google, but after open sourcing this system, there were also a lot of different another players on IT market that would like to contribute to Kubernetes. So Kubernetes is full open source product. You may also contribute to its code. You may also use it, and that will be really open source, and you'll receive the best benefits of using the open source product. And also one of the biggest benefits of Kubernetes is that you may run it on the different environmental systems. So you may use Kubernetes, for example, on the Vagrant-based environment. You may deploy it on Amazon. You may use it in Google Cloud. You may use it on OpenStack. You may deploy it locally in Linux machine. So it doesn't matter. Kubernetes simply runs your Docker containers, and you simply have to manage your Docker containers. It doesn't matter on what platform do you use them. The main components of Kubernetes, the main component is a cluster. It is a set of nodes where your containers have been run. So there are two main types of nodes that are master node and minion nodes. Master node is operating like a controller node where the main functionality is being performed, and the minion node is that node where your applications are being run. Pod is the smallest unit of Kubernetes. So when you run some application, you're using Kubernetes. You run it in a pod. So when you run, for example, Nginx-based cluster, so you have, for example, 10 Nginx Docker machines. They are all being run in a pod, and from 10 containers with Nginx, you receive one pod that you may name as Nginx pod. Application controller is a loop that allows you to state the desired amount of your infrastructure, the desired amount of your containers, the desired state of your infrastructure, and so on. So if you have, for example, a couple of pods and you should use in one pod, for example, 10 containers, but something happened and one of these containers has pinned down, so our application controller will bring up another container on another host, and you'll receive the same amount, so 10 containers. Service is a set of running pods in Kubernetes. So for example, when you run a LAMP infrastructure, so some LAMP-based application, like so you may use Apache or Nginx like a web server. You may use some containers for database management, some containers for PHP or some similar management. You may use 3 pods. You may name them, for example, web server, database management, and PHP. And all of these pods were you may run as a single service. And labels that are features that allows you to differ some different objects in Kubernetes cluster. And for example, if you have different pods, as it should be run in this pod should be run in a production environment. These pods you should run in development environment. You may mark them using labels, and you will receive the difference between them. That will be useful if you'd like to manage them much easier. This is a brief infrastructure diagram. So this is a Kubernetes masternode where the whole processes are being performed. So there is a REST API. There are some authentication information regarding who are you, what actions you are allowed to perform on this masternode being deployed. There are also the controller managers deployed and so on. So masternode is something like a controller node in your Kubernetes cluster. These nodes are samples of their minion nodes. On each minion node, you may notice that is present a service named Kubernetes. That is a service that is similar to a Marana agent on Marana-based application environment. Also you may see there are some pods where your applications have been run. Well, so that's a brief conclusion of the pod that I have told you before, and I can show you a brief demo session. So Docker provides really the biggest benefits of container usage on your infrastructure. Kubernetes provides you the really biggest benefits of portability and allows you to isolate your environment from the underlying layer. Marana provides you ready-to-use applications that you may deploy in a few clicks, and you will easily receive the whole application in that state that you would like to use. And also Marana provides you an application catalog, so you may simply use Marana as your repo for your applications. And OpenStack itself provides infrastructure as a service management layer. So you may use OpenStack for managing networks, for managing some computer sources, for providing some storage for your Kubernetes cluster. Okay, so it's demo time. First of all, I'll show you this is Horizon. That is an OpenStack dashboard. It's pretty easy to use, and if someone of you had experience working with another dashboards from Amazon Web Services or Google Cloud or some other services, you may notice that it is really easy and ready to use. So here we may see our cluster information. Here we may see our instances. There are no instances here. Well, we may go to tab named Marana, and we may start deploying our first environment. So, for example, it will be Kubernetes environment. So I'd like to deploy, for example, MongoDB application. There are some applications that are located here on OpenStack application catalog. I have already imported to our environment, but I'd like to show you in brief how to perform this. So Mongo, you may see the package named Docker MongoDB package. We may simply copy it and we may add it to our packages. Simply run an import package, create a repo, paste it, and click next, and we'll import it. Also, we may import our applications from their predefined files, like the zip archives, and we may also use them from this. Okay, so we have our application, we have our image of MongoDB. And we simply drag and drop this application into the field of configuration. Here we may set the application name, and also we may choose the host where this application will run. So you're allowed to run this application on a Docker standalone host, like a simple virtual machine that is run on the OpenStack environment with enable Docker. But you may also use the Kubernetes pod for deploying your Kubernetes-based environment. Here you may use also, you may configure the Kubernetes pod. We may select our Kubernetes cluster environment. We have no cluster environment at the moment, so we have to configure it. So here we set the initial number of minions. So that number of minions that will be run on the OpenStack environment in a default state. If we have some issues and we should increase our number of minions, we may set that number of minions here. So in this situation, we have 3 minions. We may also assign the floating globally accessible IP to the Kubernetes node. We may also provide some name convention to our Kubernetes node, and the same situation with the gateway nodes. Gateway nodes that are nodes using them, you may receive an access to your Kubernetes cluster. So going forward, here we may choose our instance flavor. That is also similar to their predefined templates on that systems that are usually used, like Amazon, for example. So M1 Small allows you to build an instance with 1 CPU with 2 gigabytes of RAM, and as far as I remember, 20 gigabytes of disk storage. Here you may use your key pair. I have uploaded it earlier. Key pair is needed to provide you access via SSH to your instances. And going next. Well, so at the current moment we are allowed to configure our Kubernetes pod. Here is our Kubernetes cluster. We may set the amount of replicas that we'd like to see. So we'd like to see 2 replicas of our Kubernetes pod. And we may choose our container host. We have already set it up. So we are ready to deploy our environment. We simply may click this button and deploy our environment. To be honest, deployment of environment usually takes some time, so I have pre-created another environment to provide you some demonstration on how does it work in real life. So here is a Kubernetes environment also with MongoDB, and you may see there the wall components. So the Kubernetes cluster, the MongoDB pod, and the Docker MongoDB instances. Docker MongoDB is available via some IP address, and this is an address of our gateway host. So go here. Okay, so you may use some notification from MongoDB driver. Also, I'd like to show you in brief the topology of our system. So here you may see our Kubernetes cluster. Here you may see our Kubernetes pod. Here is our application, and there are also described dead instances where this cluster is being run. When we'll take a look at the instances that are currently running on this environment, we may also notice that there is a gateway node, there is a master node, kube1, and there is one minion node. I have pre-configured this environment with a setup of one minion node. And also it may increase up to 2 minion nodes in a situation when we should increase our load possibilities on this environment. Well, and I would like also to show you a little demo how does it work in a command line. Okay, so first of all, we should provide our credentials to command line applications. We may see what environment do we use. Yes, sorry. Yes. So we may see that there is one environment here is being deployed. We may also take a look on their instances that currently run. So we may see there are 3 instances. For example, I'd like to check if replication controller works correctly. So I'd like to go to the minion node. Sometime waiting. So we may see what amount of our instances have been run there. Well, so you may notice that there are 2 instances of MongoDB. We may, for example, kill one of them and check if our application controller works correctly. Take a look on the status of this container. So it's up for the latest 4 days. Well, it has been spin up in a second ago. So application controller really works, and That is a real information of our system locability. I'd like to go to Kubernetes masternode, for example, and show you briefly the status of our infrastructure. Do we have enough time? Okay, I think I'm ready for questions. Yeah, please.
.NET conditions for OpenStack. So, can we develop any .NET application on Marana without Kubernetes or Docker?
So the question is Marana an application deployment system, right?
Yes.
And is it possible to deploy some applications on Marana without Docker, right? Yeah, you're allowed. So basically, Marana is not Kubernetes or Docker related system. So Marana allows you to deploy to manage your applications. But the most applications that are being published into an application catalog are being based on Docker because of the benefits of Docker that I have described before. They are based on Docker and they are based on Kubernetes because of the benefits. But you're allowed to build your own application without Docker and without Kubernetes. Please.
You mentioned some numbers about the overhead of using VM instances.
Yeah.
10 to 20%.
Yeah. Yeah.
Do you have numbers regarding the overhead of using Docker or another container-based solution?
Yeah. So the question was about the amount of overhead of Docker or containers in comparing to classic virtual machines. So regarding to some polls that I have, to some documentation that I have reviewed, approximately 1 or 2%.
1.
Yeah. So that amount that you may simply ignore, you won't see it. But amount of 10 or 20% you may notice it. So. Have I answered your question?
Yeah.
Okay, please.
Yeah, if my Docker local,
Yeah.
I want to use Docker local, for example, for its Redis. If I keep the Redis, one node, does it replicate this 4 nodes for me? If I want, for example, find how to understand which server and for my team.
I understood your question. So the question is about how you may manage your, for example, Redis cluster, how your application will understand from which container should you retrieve some key and value, right? So first of all, I'd like to explain the main concept of Docker. You shouldn't use Docker for managing databases, for managing some stateful data without mounting external volumes, because Docker is strictly stateless solution for running stateless applications. So if you, for example, restart your application that is based on Docker, all the data that has been pushed to that container, you won't see it after restart, because after restart you simply receive that Docker state that has been predefined in the latest image. That's why you should use some extra volumes where your data is being stored. And in a situation when you're trying to run some database cluster, for example using Redis, you simply connect the same storage to all of these containers. So you have multiple containers, container mines, for example, for one storage. That's why it doesn't matter if your application will ask the first one, or the fourth one, or the second one. They will all access the same data storage. And that is. Have I asked any question? Okay. Please.
In your example, you intentionally killed one Docker instance.
Yes.
And as I understand, the Kubernetes try to maintain the configured amount of the instances and try to start one more Mongo instance, right? Mongo
Yes, yes. Not one more. Okay, continue.
Yeah, that's one.
Okay. So in this demo, I show you how replication controller is a component of Kubernetes that allows you to manage the state of your cluster has been wrote. So if, for example, you have a cluster of three pods, three applications, of, for example, from three containers. So the replication controller in one pod looks what amount have we pre-configured in our replication controller configuration. We have set it up in Horizon web interface. So I put 0.2 up to amount of replicas that I allow. So our replication controllers continuously monitor the state of our Kubernetes cluster. If some container host, if some container node has been spinned down, replication controller search another possibility to spin up your dead Docker containers that has been left. For example, there is another situation. So node with broken container has been power offed and it has been rebooted. So replication controller notices that expected state of our cluster is 2 containers. Okay, that means that I should spin up one more container on another node. That node that has been rebooted is online again. So replication controller notices that at the current moment we have three containers, but we have to see 2 containers. That's why Kubernetes will kill one of the containers to expect the state of 2 predefined containers.
Okay. As you said, the rebooted Docker system loses state.
Yes. Yes. So that's why you should store all your data that is stateful. You should store it somewhere on another volumes. And in the images of your containers, you simply set up that you simply provide information for them that they should connect to the volume on a volume store, for example. And that means that if you'll spin down different containers, that they all will connect to that storage. Yes, yes.
Thank you.
Please.
Okay, I'm kind of newbie on the subject, but I would migrate to OpenStack. Is it totally free or is there any quota? So can we use it like a server, or do we?
Yes, yes. So as I told you at the beginning of our presentation, OpenStack is totally free, totally open sourced. Open sourced and really one of the biggest open source solutions in the world. You may simply download the OpenStack source codes, or may use application an OpenStack ready-to-use distribution. For example, our company Mirantis provides Mirantis OpenStack. This is our distribution, and you are simply allowed to download an ISO file, like an image that you may use anywhere, and you may simply using that pre-configured settings, you may simply set up your environment. So OpenStack is totally free for you. No. It's only the only quota for you if you'd like to use OpenStack is your hardware. If you have no hardware, you may possibly rent it somewhere and deploy OpenStack on that hardware. So OpenStack itself is free, but you should invest some amount of money, some amount of time in your hardware. So in brief, you may say that OpenStack is that solution that allows you to build something similar to the OpenStack cloud on your own hardware, or Google Cloud on your own hardware. So that is.
Do you have any idea if DigitalOcean or Amazon AWS are using OpenStack?
No, they are not using OpenStack. Amazon use their own solution, DigitalOcean use their own solution. But one of the biggest benefits, by the way, of Marana is that there are some applications at the current moment they are not released, but they are currently actively developed that allow you to to connect your OpenStack, your private cloud, with a global cloud like DigitalOcean, like OpenStack, like Google Cloud. So that should be really easy. If you'd like to develop similar applications for your own purpose, you're always welcome. So you may easily deploy a Marana application that allows you to connect your OpenStack cloud to the public cloud and that's all.
You mean we can combine together?
Yes. Yeah. So that will be called as hybrid cloud. That's also a common situation when you'd like to store some of your data on your own hardware and you'd like to store some data somewhere else. For example, if you're a bank, you don't want the data of your customers to be stored somewhere you don't know where. You'd like the data of your customers to be stored only on your hardware, only on your storage. That's why that might be the best reason for you to use OpenStack, because that's your solution. Any more questions? Okay. So, thank you for today. If you have any more questions, I'm here, so we may discuss them later in a way.